After understanding the power of database management system, the utilities of database management system, and the facilities which are being provided by the database management system, let's understand the transaction part of it, which will be enabled by the database management systems, which will be done with the help of database management systems. So, this is something known as online transaction processing. Okay, and another thing which we understand is online analytic processing, online transaction processing and online analytics processing. What is this online transaction processing, popularly known as OLTP? This OLTP is designed to manage transactions data which are volatile and break down complex information into simpler data tables to strike a balance between transaction processing efficiency and query efficiency. You want to book a ticket in a particular train. So what is happening? You want to know the availability of seats in a particular train or availability of seats in a particular theatre Audi, availability of seats not only in Audi but in a particular row, 5th row from the screen, 3rd row from the back. How it's being done will be done with the help of query efficiency. You want to know the status of your wait-listed ticket. You will give just PNR to the system and system will be able to let you know. You want to know the availability of seats in trains plying from Delhi to Allahabad. Only at a click you will be able to know that. How is it happening? This all is happening because of this query efficiency. When you are in a position to get the desired information efficiently, this efficiency is there, only then you will go for booking of ticket, that is transaction processing. So, this OLTP, online transaction processing, is in a position to help you in two things. One, query, two, transaction processing. And both the things have to be done in efficient manner. So they have to strike a balance between the two. Okay, what does it mean? Obviously, if the transaction is being done efficiently, then for next query, data processed by this transaction will be raw data. Now you can understand that whenever you will book a ticket, the next person will be in a position to know that this seat is booked. So, online transaction processing and online query has to be highly efficient, otherwise they will not be able to work. This is something known as OLTP. It cannot be optimized for data mining. What is data mining? Is finding the data which you want to have. If it cannot be optimized, then obviously the purpose will get defeated. It has to be optimized for the purpose of online transaction processing. What is this now? OLAP. This is something known as online analytics processing, a means of organizing large business data divided into one or more cubes that fit the way business is conducted. What is this cube? Okay, I have sales data of 2 products. Assuming that my company is producing only 2 products, shirts and trousers. I have sales figures of shirts and trousers of the entire country. Now, I want to see the sales of Uttar Pradesh. Now within the Uttar Pradesh, I want to see the sales of trousers. This is now a cube having multiple dimensions, 2, 3, maybe more, and the data is being sliced, cut and presented in front of you so that you may understand the volume, the nature, the properties of this data. So this is divided into one or more cubes that fit the way business is conducted. Friends, for this we have something known as database management system. What kind of database management systems we have? We have Oracle MySQL, we have Microsoft SQL, we have PostgreSQL, we have IBM's DB2, and then friends we have Teradata databases. These are the few popular databases. They are being used to manage database. This is something known as database management system. They are the softwares. They'll run on a hardware and such softwares will manage the database. This is something known as database management systems. This will be helping organizations in decision making, finding something, and will be based on SQL, sequential query language, which will work in a structured manner. So it's a structured query language also. But now the question is that should I go for this structured query language always? So if I am going for the structured query language always, it will take a lot of time. That's why we have no SQL. Now the people say we don't need SQL. SQL, you understand, is structured query language, and no means no, not only. Trend towards no, not only structured query language systems. Why? For higher performance, the speed will be high, easy distribution of data on different nodes, enables scalability and fault tolerance, which was not there in structured database management systems. It will provide greater flexibility. It will lead to simpler administration. So this is something known as no SQL, not only structured query language. Friends, another term or the concept which we have is centralized and distributed database architecture. What does it mean? It means that where should I keep my data for processing? This will have its impact on efficiency and effectiveness of database usage. Okay. Before that, let's understand what is centralized and what is distributed. Centralized means that every bit of data, every piece of data, entire data is being kept at one place. Distributed means database is being distributed, divided on the basis of certain key parameters, maybe geography, locality, kind of customers. Okay, so let's talk about a distributed database on the basis of geography, on the basis of locality. So in few cases, say railway reservation or reservation of any kind like Make My Trip, flight booking, hotel booking, or cinema ticket booking, you cannot have distributed database. Why? Because the distributed database will not be able to give complete picture to the person who is going to do the transaction easily. Only centralized data will be able to give this picture. So where and how should we go for this centralized database or distributed database systems is something we want to understand. So, centralized database architecture, better control of data quality, better IT security, and in the case of distributed database architecture, allow both local and remote access, and use client-server architecture to process requests. This is something known as centralized database or distributed database architecture. Friends, in the case of databases, we have a very simple concept which is known as GIGO, garbage in, garbage out. What kind of results you can expect from a database system or information systems will be dependent upon the data you have given. If the data is dirty, if the data is not clean, authentic, integrated, genuine, correct, then obviously the results will be same. So, lacks integrity, validation, and reduces users' trust. Incomplete, out of context, outdated, inaccurate, inaccessible, or overwhelming means you are not in a position to rely on this. This also we have understood in one of the few previous lectures, that trust on the data is really important. What is the cost of poor quality of data? What is the cost of poor quality data? The cost is lost business plus cost to prevent errors plus cost to correct errors. We have incorrect data, so we need to correct it. The process to capture the data is not in a position to help us to capture correct data, so we have to prevent errors. And because of this, we have also some loss to the business. So all the things, three things put together will lead to cost to business. This is the cost of poor quality data.